Hello everyone, so welcome to this video. So in this video, what we will do is we will continue introduce our normal distribution. In our previous videos, we already talked about what is our normal distribution and what is a standard normal distribution and there's a relationship between them. So in this video, we will use several examples to talk about how we can compute the probability and also the 100 percentile for our normal and standard normal distribution. So first, we say for the probability density function of a normal distribution, for example, on the screen, I show the standard normal distribution, which means our mean mu equals 0 and the variance sigma equals 1. And based on this, the probability density function is simpler than the normal distribution, but it's still really complicated. As we said here, we use z to show the random variable for our standard normal distribution because they are used so many place uses, it's so popular, so that's why we usually use z for show this special distribution. In our continuous random variable, we say how we can compute our random variable between like A and B. Then we just take integral of our probability density function from A to B with respect to our random variable. However, if we do that for our standard normal distribution, we can find to take integration of this probability density function is nearly impossible because they are too complicated. Is 1 over square root of 2 pi times exponential to negative z squared over 2. It's too complicated. So that's why what we need to do is we need to use a special table to help us do this. Let's first look at the example. So here, for the first example, we try to find the probability of a random variable z smaller or equal to 0. So to do this, here, actually in the appendix of probability and statistics book, we can find the standard normal table. And many places also call this Z table because we normally use Z for standard normal distribution. So this table can also be called as Z table. So for this table, we can find the probability our random variable is smaller or equal to a specific value. So if we use the graph to show this, it means the area under our bell shape, which is a probability density function graph. And this is by boundary our value of z. And this is area, which means the meaningful probability. For this question, if we try to find the value of random variable small or equal to 0, we will look at this table and then try to look for the row name, column name, and the summation equals the value we want to find. In the question, we want to find 0. So here we can find this means the first row and first column, which means 0 and 0. So 0 plus 0 is still 0. So that means the probability when the variable is smaller than 0.5, it's smaller or equal to 0 is 0.5. Okay. So besides of use this table, just recall the property of our standard normal distribution. We know this is a bell-shaped symmetric with respect to the mean, which is 0. So that's why, yes, the area on the left from the 0 to the left is also 0.5 because the area under this bell shape is 1. So on the left part is 0.5. Okay, so no matter you use table or you use a property, symmetric property of our random variable, you can find the result is 0.5. Okay, so here I already write this. So as we said, you can use a standard normal table to get this value, or you can also use our method 2. You can also use our symmetric property of the standard normal distribution, which is our N01. Yeah, so this is our first part. Let me move to the second part. second part is find the probability z small or equal to 1. So for this, because it's nothing about the axis for the symmetry, so we need to use the table to find it. So for this one, if we use the table, so you can see in the table, yeah, now we need to find the row name, column name, and the summation equal 1. Then the corresponding intersection inside our table is our probability. So if we do this, okay, you can find each of the row is increasing by 0.1, each of the column increasing by 0.01. So here for the row, let's be first look at this, and then we can find this is 1.0. So in other words, for the column, we're still looking for the first column. And then the intersection between this row and for this first column, we will find this is our value, which is 0.8413. 0.8413. Okay, so this is the value we need. Okay, so let's be look at this. Here, part 2, we know the result is 0.8413. So this is by our standard normal table. So far, so good. So this is how we can use the table to find the value of our probability, standard normal distribution, smaller or equal to a specific value. And then let's look at this example. So this example is how we can find probability random variable, standard normal distribution random variable between 0 and 1. So in our table, we know table can only help us find the probability random variable smaller or equal to one specific number. So that means here we can now directly use the table. So what we need is we know by our property of probability, or you say the property of our cumulative distribution function. So here, this probability z between 0 and 1 is equal to the probability z smaller or equal to 1 minus the probability over z smaller than 0. So we can use this 2 minus to find the probability when the variable between 0 and 1. And also in our continuous random variable, we already said previous the random variable smaller or equal to a specific number, or the random variable smaller than a specific number, they are exactly the same. So that's why in the previous equation, we can rewrite this, find the probability z smaller or equal to 1 minus z smaller or equal to 0. So now there's two probability, we can use our table to find it. The table to find these two values. If you recall what we find in the previous part, we already know this first part is small equal to 1 is A413. 0 smaller than a probability 0 smaller than 0 is 0.5. So that means for this question, the answer is 0.3413, the difference between these two. Okay, so this is how we can use our standard normal table to help us find the probability random variable between a root. Okay, so far so good. Okay. Yeah, so now I want to explain a little more about what the meaning for our random variable is between two values. Again, if we look at the graph of our bell-shaped graph, for example, here I write one line for 0 part and another line for 1. If we talk about the probability between these two boundaries, that means this is area of our random variable. Here between the area between this bell shape with these two boundaries. Why? Because this graph is a graph of our standard normal distribution probability density function. So the probability is equal to integration from the lower boundary 0 to upper boundary 1 of our probability density function with respect to the random variable, right? So in calculus, we know this is compute error. So that's why this shadow part is a meaning on graph of our probability random variable between 0 and 1. Okay, hopefully this is help you understand it. Okay, this is already our third part. So far, so good. So let's move to the next example. So next example is still our random variable is between two values, -3 and 3. So from the knowledge we have in last part, this is equal our probability random variable small equal to the right endpoint minus the random variable is small equal to the left endpoint. And then we will use our table to find it. So we will use the standard normal table. So let's first find the first probability, which is probability z small equal to 3. So if we look at our table here, now we need to move down table about the z about 3. So you can see here, this is 3. And we say z smaller than 3, so that means for the column, we'll still use the first column. So this is the value probability random variable smaller or equal to 3, which is 9987. 9987. Let's write this in our screen. Okay, so this is equal 9987, 0.9987. And then the next one, if we try to find the probability random variable smaller than -3, if we still try to use the standard normal distribution table, you can find no matter for row name or column name, they're all positive value. We don't have any option of negative value. So then what we should do, we need to use a symmetric property to find it, instead of directly use our standard normal table. So let me first explain how we can use the symmetric property to help us find the value when the variable small or equal to a negative value. So in this one, you can see here we have a graph of the standard normal distribution probability density function. So here I write two blue lines. The left is for the -3, the right is for our +3. So here, if we try to find the probability random variable smaller than -3, this is I know it's really thin, but as we say, this is tile of this graph. So this is really thin, so I can just use a highlight to try to show it. So we want to find the area on the left of -3 this time. If we cannot do it because we don't have any value in the standard normal table about negative value, we can use symmetric. Try to find the probability random variable is greater than +3. So by symmetric, what we know by symmetric, what we have probability over z small equal to -3 is equal probability random variable z is greater or equal to 3. They are exactly the same. Okay, so now if we try to find the probability of a random variable is greater or equal to 3, which is our right endpoint, the right tile here, then what we should do is we should use, again, if we want to directly use the table of standard normal table only tell us a probability random variable smaller or equal to something, now greater or equal to something. So what we need to do is we need to use a rule about our probability here. The area under this bell-shaped table, bell-shaped graph is 1 because the probability of everything is 1. And then if we want to find the right endpoint, what we can do, we can use the probability of a random variable is 1 minus random variable smaller or equal to 3. So here, z greater or equal to 3 is equal 1 minus probability z smaller or equal to 3. And we know probability z smaller or equal to 3, we already know this, is 0.9987. Okay, so this is what we need by the property of our random variable, standard normal random variable. So that's why we need this. Okay. So then let me copy this to our what we have here. So I want to copy this one. Okay. And then let me copy this, pass it here. Okay, we can now pass. Okay, so maybe let me write this again here. By symmetric and property, probability, property, right? What we know this probability z minus -3 small equal to -3 is equal 1 minus probability, or say equal probability z greater or equal to 3 and equal 1 minus the probability z smaller or equal to 3. And then this equal 1 minus 0.9987. And in other words, if you use your calculator, you'll find this equal 0.0013. So this is our probability for random variable z smaller or equal to -3. So then what we will have is, based on this, we plug in these two equations into our previous two probability. So that means this one will equal 0.9987 minus 0.0013. So if you use your calculator, you can find the answer is 0.9974. So this is our answer. So for this question, when we have a random variable, which is actually between range with left endpoint equal a negative value, right endpoint is equal a positive value, we can now directly use our standard normal table twice to find this difference. We need to use the property of our standard normal distribution. Okay. So this is not an easy one, so please make sure you practice this with other value, other range, one by one to get more familiar. Okay, so this is answer for part 4. Okay, so I also show this answer again. Okay, so this is for our standard normal distribution. And then if we don't have a standard normal distribution, how we can find the probability random variable, which is follows a general normal distribution, which means the mean mu not equal 0 or variance sigma square not equal 1. So what we have introduced in our previous video, we already introduced this theorem. When we have a random variable follows a general normal distribution with mu as mean, sigma square as variance, then after the translation of x minus mean divided by standard deviation sigma, we can find this new random variable is follows a standard normal distribution. So that means if we want to find the probability of normal distribution between a range, we will first convert it to standard normal distribution with a new range, and then use the table to help us do it. So here, let me use example to show it. Okay, so the formula I can also provide it. So if original range is A and B, then after this transition, we will use A minus mean divided by sigma square, right? And right endpoint B minus mean mu divided by sigma square, standard normal distribution, standard deviation. So here, this is example. If we have a random variable follows z, here x follows 3, 10, 3, 16. So here first, by this one, so we know because we have our random variable x, right? X follows, so here 2 times means this follows a specific distribution. So based on this, we know what is the mean of our x. So here I use x, ex, this is equal 3, and the variance of our random variable equals 16. So based on this, we will know the standard deviation is a square root of variance, so which is square root of 16. That means yes. So based on this, we already find what is our mu, or say mean is 3, and what is standard deviation of sigma is 4. So then for our if we say like again z equal our x minus mu, and then divided by our standard deviation. And so here I say sigma, which is our standard deviation. So we know this one will follow a standard normal distribution. So that means based on this property, we can rewrite our previous question for small equal to x, small equal to 8, to our random variable 4, which is by the transition 4 minus mean, 4 minus 3, divided by standard deviation, which is 4, small equal to our z, small equal to the right endpoint, which is 8 minus 3, mean divided by standard deviation, which is 4. And by some calculation, we know now the left endpoint will be 0.25, small equal to z, small equal to right endpoint 1.25. Of course, you can use your calculator to help you check this. So now we find z follows a standard normal distribution. Left endpoint is 0.25. Right endpoint is 1.25. So then what we do is follows our previous example. This probability will change to 2 parts. One is our random variable small equal to the right endpoint, minus our random variable is small equal to the left endpoint. And then we should use our standard normal table to find the value. These two probabilities. Okay, so here, this part is, let me give maybe 1 minute to look at, I will show the table on the graph. Please try to find what is the value of our random variable small equal to 1.25 and 0.25. Okay, so for 1.25, what we should do is we can use our graph to try to get it. So you can see for here what we have. We have 1.2 on this row, and we need to find 1.25. So that means in this row, we need to find the column give us extra 0.05. So we say this column. So that's why for our answer, the answer we need is here is about 0.8944. 0.8944. This is our random variable standard normal distribution, small equal to 1.25. Okay, so far so good. And then for the 0.25, again, we try to find the row 0.2. Okay, and then we will look at this row 0.2, and then also we need to find the column to give us actual 0.05, which is here. So the intersection here we find is this number. So it's 0.5987. 0.5987. Okay. So then we plug in this two value into our equation, and this will give us the answer. So here, I give you the step answer here. And this is how we get this result. And then you use calculator to get the final answer. Okay, so this is how we can use the relationship between a standard normal table, standard normal distribution, and normal distribution, and also standard normal table to find the probability of random variable, or say a normal distribute random variable between a range. Okay, so this is our second example about normal distribution. So the last topic I want to talk about here, and also an important topic for the normal distribution, or say standard normal distribution, is our percentile, 100th percentile. 100th percentile is a number which we will try to find, and this number will give us random variable, or say random variable smaller or equal to this number is equal what we want. If we write this as our integration, this is a notation. Integration from the negative infinity to pi p of our probability density function, this value is equal what we look for, which is value of p. And the notation for our p's percentile is pi p. So for this, I understand it's kind of abstract, hard to understand. So then let me use one example to find it. So if we have a course, this is a normal distribution, follows mean equal 25, variance equals 36. So here, based on this knowledge, we know what we have. We know X is a normal distribution, but it's a mean with EX, mean equal 25, and the variance of X equals 36. Right, so here, if we try to find standard deviation, and this will equal square root of 36, so answer is 6. And now, if we try to find the random variable X, and is 90th percentile, what we want to do? Actually, this means we try to find our random variable X smaller or equal to something, and give us a result is 0.9, or say 90 percentage. So here, what in our rectangle, this number is what we look for. This is something we are look for, right? So previous we say you can use pi to show this, or if actually other table or other textbooks, you can use different thing to show it. But what we try to find is we try to find this one, something in this rectangle. Okay, yeah. So then for this one, now what we can do is, let me make a question mark inside. Maybe this is more clear. So to do this, what we will do is, okay, so here, if we again use the standard normal table, what we need, we can rewrite our equation to, again, a standard normal distribution. So that means we use Z to show our standard normal distribution. This is equal X minus our mean, which is mu, X minus mu divided by sigma square, sigma instead of sigma square, because it's a standard normal, this no standard deviation here. And in this question, it means here we will have, this is what, X minus 25 divided by 6. Okay, so if we let this is equal Z, that means the previous equation will change to another thing. This is we try to find our Z, which is a standard normal distribution, smaller or equal to a question mark we try to find, minus our mean, 25 divided by standard deviation, and then this is equal 0.9. This is what we look for. This is what we look for. Okay, so if now we try to find something inside this part, let me again use like a rectangle to circle it. So this, how we can find this value inside this rectangle here? What we should do is we should use the standard normal table to find it. So here, what we need to use the standard normal table to find the value in the rectangle. So here, let's look at the table here. So table, we know the probability we look for is 0.9. But now we want to find the value or the range of z smaller than this range. So if look at the table, so now instead of look at the row name, column name, the summation equal our range. What we have, we know the probability. So that means we know the number inside this table, right? The number inside this table. And then use the value inside the table, we will try to find the range, which is row name and column name summation. And for here, we look for 0.9. So if we look at the table, do we have something equal 0.9? Unfortunately, we don't have it. You only have something close to 0.9. For example, here we have 0.8997, 0.9015. So here, what we do, if we cannot find this exactly probability inside our table, we'll just find the one close or say closest to our value. So in this two, what I should find instead of find 0.9015, of course, 0.8997, this is more close. So that's why I use this value. This is what I look for. So let me, instead of use a highlight, let me use a circle to cover it, 0.8997. So after we have this value, what we do, so here it's kind of backward what we do before, right? Use another direction. We have the value in the table. We will go back to look at which row they satisfy, which column they state. So for the row, if we go to left, for the row name of this one is 0.2, 1.2. And for the column, which column we are looking for is this column, is 0.08. So that means after we find the probability inside the table, we go back to look for the summation of the row name and column name. And then we will find the answer of our value in the rectangle is 1.28. 1.28. So this is what we look for. So then use the table, we will find the table finding the rectangle, so find value close to 0.9, then the corresponding row name is 1.2 and column name is 0.08. So the summation is 1.8 plus 0.08. 1.2 plus 0.08 is 1.28. So this is our value in the rectangle. So in other words, what we have the question mark minus 25 divided by 6 equal 1.28. So then after we have this, next step is we try to find the value of our question mark. Okay, so then this is about algebra. So by algebra, we know question mark is equal what? Is equal 25 plus 1.28 times 6. Okay, so now you should use your calculator to compute this value. Okay, so I give you 1 second to do it. What is the value here? 25 plus 1.28 times 6. Do you find the answer? So the answer should be 3.68, I think. 68, if my calculation is correct. Yes. Okay, so this is our answer. Okay, so this is later. Well, yeah, so as we said, try to find the value. So here I use C instead of question mark. The idea is same. And then you can find the answer. The answer is 32.68. And this is the 90th percentile of our random variable x. as a normal distribution follows mean equal 25 and variance equal 36. Okay, so this is end of the example and also end of this video. Hope you enjoy this video, and please leave any question on the comments and give me some feedback. Thank you for your attention. I will stop this video.